Okay, so I'm going to do this practice problem for you guys first, and let me go back a couple of pages for the key vocab. So you can go ahead and write these key vocabulary words down in your book creator, and you should already have the definitions from class, so just write them down again in the book. So this says, what is the equation for the function? So here's this graph right here, and it wants us to write an equation. And our equation, and I'm going to write the answer up here, is going to be y equals, or you can say f of x equals, either one will work, and I'm just going to do a, and then I'm going to go with my first root, which is 1, 2, 3, 4. It seems like I get x, and since this is negative, I'm going to write the factored form, 4.25. And because it goes straight through, the multiplicity is 1. And remember, we don't write that 1, but I'm going to write it for your sake. And then the next one is, the next 0 is at 1, 2. So I'm going to say x plus 2 to get that root in its factored form. And since that line goes straight through, it has a multiplicity of 1. The next root seems to be at x is 1. So I'm going to say x in the factor form is minus 1. And because it goes straight through, it has a multiplicity of 1. And then here, the next one is, looks like to be at 2. So I'm going to say x minus 2. And because that line goes straight through, it has a multiplicity of 1. And then the last one seems to be at 2, 3, 4, and maybe 4 and maybe 4.75, x minus 4.75. That's in its factored form, and because it goes straight through, the multiplicity is 1. So that's part of the equation for the graph. Now, I'm almost finished with it, but I need to find A. In order to find A, I need to know what my y-intercept is. So my y-intercept right here is 1, 2, is 0, negative 2. So to get the value of the A, then I'm going to say negative 2 equals A, and everywhere there's an X, I'm going to put the 0 because I know that my y-intercept is at negative 2. Oops. And you know what? I'm not going to keep writing those, guys. We already know anything plus 0 is just that number. So I'm just going to say 0.25 times 2 times negative 1 times negative 2 times negative 4.75. And then I'm going to use my calculator to help get me the math here. So I'm going to say, you can use decimals and type it in just like what I'm typing in. And decimals is on your PDF from class, or you could just Google it. Negative 2, that, negative 4.75, close that. And okay, so I get negative 2 equals, what's that number? Negative 80.75 times 8. And then I'm going to divide by negative 8.75 to get the value of A. And then, just because, okay, I'm going to leave it this time. Divided by negative 2, anyway. So I get negative 2 divided by negative 80.75 equals, and I'm going to get the fraction form of that. I don't like decimals. So I get 8 over 3 to 3 equals A. So the answer to part A of this question is y equals the A value, which is 323 times x plus 4.25, x plus 2, x minus 1, x minus 2 and x minus 4.75. All right, that's the equation to part A. And we went over last week how to get the equation, so you might have to go rewatch that video. Now it says, is the highest degree of the function even or odd? We get the highest degree by adding up the multiplicities. So 1, 2, 3, 4, 5. And so we're going to say the highest, and I'm going to use short terms. I'm going to call the highest degree HD is 5. So we're going to say not even, but odd. 5 is an odd number. What's the relative maximum? The maximum means the highest point, and we do that by the y value. So, and I'm going to highlight this. This is a maximum, and this is a relative maximum because it's the maximum in that area, and this is a relative maximum. It's the maximum in this area. So it's the high points in the graph. So you read maximums by the y value. So you would say y equals 2 and y equals 1. Okay, what are the relative minimums? I'm going to do those in yellows. These are the low points in the graph, the little lower loops. All right, so the relative minimum would be y equals -3 and y equals -1. Okay, the next part is, does the graph have even symmetry, odd symmetry, or neither? So in class, we talked about symmetry is the ability for the graph to reflect itself when some kind of movement of it is done. So the ability of the graph to reflect itself when some kind of movement or some kind of figure is placed on it. So there's two things we need to check. If I fold this graph in half, or if I put a line straight down the y-axis, does this graph get split in half? So the answer to that question is no. This graph does not get split in half when I go put a line straight down the y-axis. This arm does not touch this side, and this side doesn't touch this side. It's not reflexive. It doesn't split the graph in half. Another thing you need to check for is if I turn this graph 180 degrees, so if I turn it upside down, watch this. And this is how you can test. Just a minute, babies. All right, so what you do is I want to check. I know this graph doesn't have even symmetry because if I put a line straight down the middle, it doesn't split in half. Now I want to check to see if it has odd symmetry. So I'm going to turn this graph upside down and see, does it look exactly the same? No, it doesn't look. This graph, if I take this graph right here and turn it upside down, it doesn't look the same. So I would say this graph has no symmetry. No symmetry. It's not even and it's not odd. So the next part is what is the end behavior of this function? And the word end behavior is what's going on at the end. So here's what we're going to do. We're going to put a little box at the ends. A little box at the ends. Okay, the x is going towards negative. These x values are getting small. The y value is pointing down. So the y value is getting small as well. So I would say negative. Over here, the x values on this side, they are positive. So I will put positive infinity. They keep getting bigger and bigger. And that arrow is pointing up. So you will write positive as well because these numbers keep getting bigger and bigger. So I would write this as, you would say, the end behavior would be as x approaches, and let's do the left side first, negative infinity. I'll say left side go first. As x approaches, this is the x, negative infinity. As f of x, or the y, approaches negative infinity as well, because the y values are going to be negative because this is pointing down. And then for the right side, I would say x is going to approach, this is the x-axis, positive infinity, as f of x, or the y, is going to approach, and you see how this is positive? You would say positive infinity. Then the last question asks, what is the intervals of increasing and decreasing? All right, so to get that, I'm just going to read this graph from left to right, and remember intervals of increasing and decreasing is read by the x values. So I'm going to trace this graph, and I notice that the graph is going up. So if I'm coming from the x values, I would say from negative infinity to whatever the x value is here, to 3, and we're going to include this, the graph is increasing. And then I'm going to draw another arrow going down, because that's going down. And then we're going to say from 3 to, what's the x value right here? Because it's going to start changing directions. From 3 to negative 1. And I'm going to put them both in brackets because they're both included. The graph is decreasing. And then I'm going to draw another arrow because it changes direction again. I'm going to look at the x, and I'm going to say from negative 1 to the next x value, which is 2, and I'm going to put it in brackets. I'm going to say it's increasing. And then I'm going to go down from there. I'm going to say from 2 to the next x value to 4, the graph is decreasing. And then from 4 to positive infinity, because the x value here is going to go on forever, the graph is going to increase. And never put infinity in brackets because it never stops. It keeps going. Only thing that goes in brackets are numbers that are included in the set. All right, so I want you to try this next one. And of course, you know, if you have any questions, please come to tutoring or come to class, and then we'll talk about this. Bye-bye, baby.